Okay, so Riemann sums part 2. And it was a clean break because on yesterday, Thursday, all of our problems were in table format. So it was really just about understanding what we were doing and then going and grabbing the right value, whether it was left, midpoint, or right, or trapezoid. But we get to number 3, and we don't have a table, but they still say approximate this, and remember this means area under F from 0 to 2. So they want us to approximate the area under that function using a left sum and 4 equal subintervals. So I'm going to have 4 rectangles. Still going to be base times height, base times height, base times height, base times height. But I don't know. I've got to figure out what the base is and what the height is. Perhaps a little bit of a sketch would help. I want to go to 2. So, that's a start. If I want 4 subintervals and the total width is 2, then how wide is each base going to be? 1. I'm going from 0 to 2. 0 to 2 over 4 subintervals. So total width over the number of subintervals. So for this problem, that's a half. Now I'm just like internally debating, do I want to go half or 0.5? It doesn't really matter because we're going to safe stop this thing and just leave a bunch of 0.5s and 1.5s. Okay, so I know each rectangle is a width of, or a base of 0.5. I don't really know what this shape looks like, but I don't really care. Like, I don't know what it does. The point is, now I've got intervals, and it says use a left-hand sum. So let's start adding up my area here. Is approximated by, the width is 1/2. How am I going to find the height of that first rectangle? Plug in. Plug in is right. Which side do I want to plug in? The left side. So I want f of 0. F of 0 is easy because plugging in 0 is pretty easy. But I'm talking high level right now. We'll figure out f of 0 in a minute. My next rectangle still 1/2. How am I going to find the height of that rectangle? F of 1/2. You do a couple of these, you start to say, wait a minute, I sense a pattern going on here. But you don't have to worry about a pattern, you're just adding rectangles. Plus 1/2 f of 1 plus 1/2 f of 1.5. Big suggestion to sort of make sure, as a bit of a check, 4 subintervals, make sure you're adding 4 things. Or you got 4 products here. 1, 2, 3, 4. Because it's tempting to notice the pattern. You'd be like, oh, I see the pattern. And you want to guess what a common mistake is? To go to 2. Because like, well, that would be the next thing in the pattern. But I've already got my 4 rectangles. Can you like put into words why we don't use f of 2? Because we're just using the left-hand sides. If we only use the right-hand sides, which height would we not be using?
0.
F of 0. So be careful. Again, the common mistake is to write a few and be like, oh, I got the hang of this. I see the pattern, and I need to go to 2, so go to 2. But that would give you 5 rectangles, and that would really give you, like, it would give you this rectangle over there, but that's not what we want. Okay, so like concept-wise, we're done with this problem, but that's not a safe stop yet. Do you know why it's not a safe stop? I got to plug it in. I got to show what f of 0 is. So f of 0 is, well, that's an easy one. I'm not going to plug in all the zeros. I'm just going to say 1. F of 1/2, oh, I switched up here. I did 0.5 here and 1/2 here. Either way, means plug in 1/2. But now that's a safe stop. I don't have to evaluate. I do have to plug in, but I don't have to evaluate. So if I do that for f of 1 and f of 1.5, I'll be done. And I mean, 1's pretty easy, so if you evaluated 1 just because you're like, God, that's easy, I can do that, that's fine, but you can also just leave it as is. And then f of 1.5, same type thing, plug in 1.5. I definitely don't want to evaluate 1.5, because I don't want to cube 1.5. I don't even really want to square 1.5. So it's like all of that sort of put together is your answer, and that's a safe stop. And you may feel like, well, that's a lot of work left undone. Like, well, yeah, but it's work you don't have to do. And so on this next test, I think I mentioned this, I pulled off a bunch of the multiple choice because I want to work on safe stopping, basically, to sort of emphasize, show your work, safe stop, and so, yeah, you don't have answers to choose from, but you also don't have to simplify. And you can also get more partial credit because I can see the work done. Okay, so let's back up and think big picture here. Up until now, they'd all been table problems where we could just pick the heights off the table. This one, they didn't give us a table, they gave us a function, so we had to plug things in to get the height. So finding the heights was a little bit trickier, but it was still the same process. What I said at the very beginning of yesterday, all we're doing is adding rectangles. Dylan?
Why don't we underderivative that one? Like, is the integral sign?
Oh, that is a great question. The question was, why don't we underderivative this one? Because of the interval sign, or the integral sign. That sort of gets into what we're going to talk about next week, where we make this connection between the area under the curve is the underderivative of that. So, you're right. If all it said was this, if it just said find that, then we'd have to do the underderivative, and I don't even know that we've done this yet, where you plug in the top minus plug in the bottom. We've not done that yet. That would give us the exact area. But this says approximate, and it tells us how to approximate it. So that's why we don't do the underderivative. But it's a good question because the underderivative would give us the exact area. So it's like, why are we approximating when we can easily find the exact area? We're approximating because sometimes you get really complicated things that you can't underderivative, so you need an approximation. Another side note, when you ask your calculator to do this, which we'll do later, you think it's doing this, the underderivative, but really it's doing this with just a whole bunch of intervals, like a whole bunch of rectangles. Because the calculator doesn't know calculus, but it can do a bunch of calculations really quick. So when you ask it to do an underderivative, it doesn't really do an underderivative. It draws 100 rectangles or 1,000 rectangles and adds up those areas really quick. And if it does that many rectangles, you're like, well, it's close enough to 3 decimal points. So but you're on to something there, because we'll do that next, basically, and make that connection between area, exact area versus approximate area. Number 4. The amount of water draining in a tank is given by a strictly decreasing function. Okay, strictly does not mean like you will follow the directions exactly as I asked. Although it kind of means that, actually, because strictly decreasing means always decreasing. I guess it sort of does mean strictly in the normal sense. No budge at all. Like, we are always definitely decreasing. see when or if that matters. Using a right Riemann sum with 4 subintervals, which makes sense because it looks like I would have 4 rectangles there. Approximate 0 to 40 W of t dt. To Dylan's question about exact versus approximation, there are times, like in the real world, where you have measurements, but you don't have an equation. Like, I don't know what the equation for W of t is, so I can't do an underderivative. But if for some reason I need this value, I could record some measurements and approximate it using a right Riemann sum. Okay, let's pick on people here, because a good little review. So that looks like 4 rectangles I need. So McKenna, who just stepped out, she had a feeling she was going to get picked. Jason here. Abby's here. Johnny and Dylan. All right, Autumn, how about the first rectangle? What's the area of the first rectangle going to be? How wide is it going to be? 10 wide. And then which height should we use? The right one. And which number is that? 78.3. All right, Abby, how about my next rectangle? 5 wide times 71.1. Johnny, how about my third rectangle?
10
Perfect, the right-hand side. And then Dylan, how about the last rectangle? So 15 times 43.2. It asks for 4, so 1, 2, 3, 4. And again, safe stop, leave it alone. Part B. Is your answer to Part A an overestimate or an underestimate of the actual value W of t? Explain. Why do you say under?
decreasing, so if you're using the
That's exactly the right answer, including the explain your reasoning. So a picture might help. It's decreasing. Again, that didn't have to be perfect. And so if we draw some intervals on a decreasing function, and then we use the right-hand height, then that's an underestimate. So that's not like a memorize, we talked about this a little bit, don't memorize all the different combinations. Like, think about what's given and what's asked, and you can figure out if it's an under or an over. And the reason is exactly what Dylan said. If we use right, and you can say right Riemann, or right sum, or right rectangles, like the main word is right. Right rectangles on a decreasing function. You'll always be under the function. And again, I think there are still students who like memorize all the different combinations. Right and decreasing is under. That means right and increasing is over. No, don't. Like, there's too many ways to get them confused. Like, just draw the picture and figure out the question. Okay, so the only thing we added today was this not using a table, but using a function. All right, let's move to the